So, hello everyone. Do you hear me? Are you tired? I guess it's the end of the conference, almost the end, and only 2 talks left, so just be strong. I hope not to be very boring. And where's my slides? I think I need my slides, because it's difficult to present without them. Oh, yeah. Finally, we have it. By the way, just check if you're in a proper room. Maybe you wanted to listen about something else, but I'm talking about microservices with Kotlin and gRPC. First of all, please raise your hands if you're already familiar with Kotlin or gRPC or both stuff. Oh, pretty much. Usually it's less people, so I'm really happy. I guess all of you, even if you're not familiar neither with Kotlin or gRPC, you'll be happy and find something new during this talk, or at least enjoy it and have fun. First of all, let me introduce myself. My name is Marharyta, and I'm software engineer at Wix.com. So, like most of you, I'm also a software engineer. I'm writing code on a daily basis, but I'm also an active community member. I like to organize some meetups, conferences, and like DevOps in Ukraine. And I'm also organizing Kotlin Night in Kyiv. It's a conference totally devoted to Kotlin. And sometimes I speak at some meetups, conferences, so you can meet me. By the way, one really important thing you should know about me. I like boxing very much, so think twice before asking tricky questions. Of course, I'm kidding. I won't hit anyone, at least today. So let's start. Today we'll talk about gRPC, because as I understand, most of you don't know what is it. Then we'll talk about a serialization protocol used in gRPC, it's protobuf. Then we'll implement some simple service, we'll write interceptors, we'll do error handling, we'll test everything, and we'll discover some interesting libs for Kotlin and gRPC. But before we start, let's think that in the very beginning it was a big monolith, because most of you, if you came from previous decade, you were working with monolith. And today, microservices is a trend. So big monoliths built into millions of microservices, and most of you are doing microservices today. That's why I ask you to raise a hand, those of you who are writing microservices today. Don't be shy, it's okay. We do it as well. So most of you are writing microservices today, or at least think they're doing so. So it's okay. Why do we like microservices so much? Because they rock, and we can be independent. We can scale everything. We can mix different technologies and choose the most proper technology. For example, you can write something in Node.js, something in Java, and to choose whatever you want and whatever is most suitable for you. And then, of course, you can do development in parallel, because one team works in one microservice, another team works in another microservice, and everyone is happy. Just define some contract, and you work, and everything is okay. And, of course, we can talk a lot about pros of microservices, but there is always one but. We cannot talk a lot about pros without saying about cons. So the biggest issue in changing a monolith into microservices lies in changing the communication pattern. What does it mean? When we worked with monolith, we just called some service, we called function, and we were on the same server. So we were happy and everything is okay, it worked. And now when we're working with microservices, we need to change something in our mind, because now we are not calling our services directly. We are using network. And network is something that is not reliable by default. You should think that it's always down, and you need to keep it in mind. So this is the biggest problem of microservices. And by the way, who said this? Do you know? I actually won't ask you. I will ask you a lot of questions, but don't be shy, you can answer them. Actually, it was Martin Fowler. It's a really smart guy. And he wrote a lot about monolith and microservices, so I think we should listen to him. So we decided that we're using microservices today, but how we communicate between microservices? Please raise your hands again. It's like a workout. Those of you who are using HTTP1 and REST today. Most of you are using HTTP1 and REST, and actually in Wix we also use HTTP1 and REST because it's a common way, it's simple, it works, and why should we use something else? Sometimes we face some problem. Sometimes we have a lot of clients. For example, at Wix we have 140 million of users, and it's a lot of requests per day, a lot of requests per minute, and we need to have more and more servers. We need to pay more to Google Cloud, to Amazon, and it costs money. And it's a problem, because the more money my company pays to some Google Cloud, Amazon, Azure, it pays less to me, and I'm not happy with the situation. I would like to earn more money, so maybe we can somehow change it. gRPC is not a silver bullet, but it can help us. Why gRPC can help us? Let's discover what is it. Actually, gRPC is like a library which can help you to build your communication between microservices. Why it can be so efficient? First of all, gRPC is built on top of HTTP 2. I guess most of you heard about HTTP 2, but I'll tell you a little about this protocol. Let's dig a little bit into its evolution. In 91 it was 0.9, then in 96 it was 1.0, and then no progress, no progress, no progress, maybe they're not alive. And suddenly, in 2015, HTTP 2 appeared. So, of course, it's a joke. They did cool stuff, they worked all the time on that protocol. But I would like to show you that the whole internet changed, the whole world changed, and we still were using, and again, now we're also using HTTP 1. So it's something that is really outdated, and we need to switch to HTTP 2. So I'll tell you about some key changes of this protocol. First of all, finally, HTTP 2 opens single connection per client. If you remember, HTTP 1 just opens connection per request and then close it. There was an option like keep alive, but it is not what you think it is. It can stop with timeout, and there are some issues with it. So HTTP 2 actually opens one TCP connection, and it's always opened. And of course, as we have this open connection and we can communicate between client and server, we can use it as bidirectional streaming, so we can multiplex it. For example, our client can send a lot of requests to our server, and again, our server can send a lot of requests to our client. And one of the key features of HTTP 2, which is used in gRPC, is flow control. Sometimes you face a situation when your client cannot handle all the requests your server sent to it. For example, we have laptops, we have mobile clients, we have like desktop clients, and for example, mobiles are not as efficient as laptops, and maybe they need some slower pace. And flow control can help us to tell our server that please stop. I cannot handle all the requests. I will handle this batch of requests, and then you'll send me a next batch. And that's how you make your client. You don't make your client to be down. So, and everyone is happy. Your clients are happy, and it's an important feature. Actually, in HTTP 2, there are a lot of cool features, but we won't dig a lot into it because our talk is not about HTTP 2. You just should consider that it's a cool protocol, and you should look into it. Then, gRPC supports multiple languages. gRPC just tries to be language agnostic. Of course, it's not true because it needs to be compiled to different languages, but they try to support as many languages as you can. And for example, at Wix, we're using Scala. I also have Java. We have Node.js, and we are going to have Kotlin. So it's okay to be language agnostic and to use gRPC. And the main advantage of gRPC is its binary. First of all, because HTTP is binary protocol, HTTP 2 is binary, and because we're using protobuf as a serialization protocol, and data that is transferred between our client and server is binary. And As you remember, HTTP1 was a string protocol, and sending strings is quite expensive than sending bytes. So these main features can assume that gRPC could be more efficient than another approaches. So at Wix, we find out about gRPC, we tried it, and actually it works for us, and we like this approach, and we are happy with it. But in Wix, we are using gRPC with Scala. We have a lot of Scala, and as Scala is not supported by default, there is a library called Scala PB, and we are using it, and we build a lot of stuff on top of Scala PB, and make gRPC more user-friendly to our programmers. But there are some problems. For example, Scala developers are hard to find, and there are some cases when we want to try Kotlin. And we started thinking, is it possible to introduce Kotlin with gRPC into our existing frameworks? Actually, it's still a question because we have a POC, but it's not still in production, but we are working on it. So that's how this talk appeared. Let's summarize a little bit about gRPC. The key feature that we will talk about today, it's HTTP2, it's multilinguality, and it's binary. So next step is protocol buffers. It's serialization protocol used in gRPC. So according to Google, at this boring definition, think about protobuf like it's XML, but smaller, faster, and simpler. So let's forget about this boring definition, and let's have an example. You define proto file. You can see that it's not an XML, it's not a JSON, it's a kind of pseudo language. So you're writing your service, and in your service you're defining the name of your service, and request and response, so parameter that you receive and what you return. And under it, we just explain what these messages mean. So hello request is just string name, and hello reply is just string message. So that's how a simple proto file looks. And then you have this proto file. You compile it with some plugin, for example, gRPC Java or gRPC JS or something else. And you receive some classes in your languages that we choose. I mentioned in this slide only languages that are officially supported, but there are a lot of additional libraries that you can choose, and this list is much more bigger. So let's summarize what protobuf is and why it's so efficient. First of all, as you compile it to your language, and if your language is type-safe, for example, like Kotlin or Java or Scala, your communication is type-safe, because you won't pass wrong message, because you have compile time error. And then according to this, you won't violate your schema, because your service is compiled to the interface of your language. And that's how you cannot pass wrong parameters to your PC call. And the serialization is fast, because it's just serializing into bytes. And one more important feature of protobuf is that all fields of message are optional. And that's why it's you can easily duplicate some fields, and you can easily add new fields. So it will work in backward compatibility. But the main problem of protobuf is human readability. What I mean, if you have one server and another server and they're communicating and sending only bytes, and when you're debugging, you see only bytes. And I don't know how many people can read bytes. I'm not sure that's a lot. So if you need human readability, protobuf is not something you really need. But if you don't really need it, you can. It's your choice. So that's enough with talking, this boring stuff. Let's implement some service. As I am a huge fan of Star Wars, maybe you've seen it in my slides, I decided that we should build a Death Star, this tiny little Death Star that can destroy planets. So, task for today's session. First of all, we need to write a Death Star and destroy planets. Then we destroy as much planets as you can. And tweet about it, of course, with these hashtags. And at the end of the session, the person who wins this contest and destroys as much planet as he can will win some present from me and Wix. And of course, enjoy this session. So, as I prepared to this talk, I already built this Death Star, and the application is available here. You can go there, and you can start, and you can actually destroy planets. You just need to enter your name and click on planets. Do you need? Can I proceed? Okay, let me proceed. Maybe you can take photos in order not to stay in this slide more. So, let me explain what is this application. In this application, we have two main flows. First of all, when user joins, when you enter your name and you join our application, what happens? You're going to Death Star service, and you register there. Death Star also going to Planet service, gets all planet that we have in our universe, and returns it to our user in order to paint all this stuff. Then we also subscribe to logs and subscribe to scores in order to see scores of another user, in order to see some logs, what's happening with this application. And we receive some stuff from these services. And another action is more interesting, is destroying. When we are destroying planet, we're using streaming. So we are constantly streaming to this the star request. Our client sends a request to destroy some planet. If everything is okay and planet is destroyed, we are going to Planet service and we delete the planet. Because it's destroyed, we don't really need it. And then Planet service generates new planet and notifies our Death Star that new planet is generated. Then we are going to log service and log everything and update scores. And of course, we notify user about everything that happened. It's not like the best architecture ever written, but it's how it works. So let's implement it. First of all, we need to start from proto file. It's a good solution to start from API. So we define service Death Star service and gRPC call called destroy. You can see that destroy call is streaming, so it's bidirectional streaming. Your client streams a lot of destroy requests, and you're all the time constantly returning some planets to our client. And you can see that here you can see messages. What is planet, what is destroy request, and what is planets. Actually, it's not really interesting. The most interesting part is we are using some magic with gRPC Java. And we see this class is generated. So Java classes are generated. We won't dig a lot into it because code is not very pretty. So let's move ahead. And then we do some coding and we write server. Actually, I won't return to it anymore because it's trivial stuff, how to write service. We just need to understand that in this line we add our implementation to service, and here is a port where our service is available. Then we code again, and we actually implement the destroy method. It's like the key of our talk. So in our destroy method, what we are doing? First of all, we need to register our client. Because we're using gRPC Java, we don't know, Java doesn't know nothing about coroutines or something else. We use stream observers, and we have this stuff. We add in our observer to our listeners, then we go to Planet service and get all planets, and generate and notify our user what planets we have in our universe. And then we need to return some stream observer. So that's the whole destroy method. Of course, I'm kidding, it's not the whole method. The most interesting part is here, so let's dig into it. The most, the key feature is implemented here. So when user destroys planet, what are we doing? First of all, we are removing planet. Then we update score. Then we log that planet was destroyed. Then new planet is generated, and then we notify again our user that our universe changed. And that's how this method looks. Please raise your hand if you like it. Oh, you're crazy. I don't like it. What's the problem with this method? This stuff. These stairs are called callback hell. Because we have Java and we have stream observers and we need to pass callback all the time, and we finding ourselves in the situation called callback hell. Maybe it's not too common to Java programmers, but for JavaScript programmers it's like a huge pain. It was unless they introduced some cool stuff. So callback hell is a bad situation and we need to somehow handle it and to get rid of it. Why don't we use futures? It's an obvious solution, so we need to refactor our code. And now we have futures. So the first line is the same. We add our response observer to our client to listeners in order to subscribe to updates of destroy method. But then we are starting coroutine. And we are going to planet service, we get in all planet, and you see that await method appeared. Because when we are going to another microservice, it's suspended, and we receive like a future with some parameter. And in order to get that parameter, we need to call method await. And then we notify our observer about our planets. And again, we need to return stream observer. And look into what we have here. In this slide, we also have the same code, like we removing planet, adding score, logging everything. But what changed? Actually, we are not passing callbacks. We are doing straightforward code. You see that we remove planet, we add score, we destroy planet, we generate new planet, and we log about it and notify all our users about it. So now we don't see this callback hell. But again, do you like this code? You're afraid of me? Yeah, this code is much better than previous one, but it's not ideal, so it's not cool. I want something else. And if we are talking about gRPC Java, at this point we should stop our talk and say that nothing better could be done. But we need a new hero, and we have it. We have gRPC Kotlin, and we can use it. Who are we? We are Kotlin developers. And what do we want? We want to use channels. The main problem in this code was stream observers and callbacks. And if we are using futures, we cannot get rid of it. But if we can use channels, we can get rid of it and make our code more straightforward. So again, we have a little bit magic called gRPC Kotlin. And what do we have? Now you see that we are not working with stream observers, we are working with channels. Channels is like structure from Kotlin coroutines. It's like a list. You can think of it like a list or a stream, but when you are taking element from it, you are suspended unless element is here. So it's like a channel of communication between different coroutines. And again, we are subscribed this channel, and we return the same channel. And then we are launching coroutines. We are sending all planets that we have to the channel. And the coolest stuff that we do not do any stream observers here. We are just iterating over this channel like it is a list. Isn't it magic? So requests is just stream. So your client constantly sends some requests to you. But in code, you can iterate over it with for loop. So you're just iterating, you're removing planet, add score, you're destroy planet, you're logging everything and generating new planet and notify everyone. So this code looked this way. What do you see? We have less lines of code, and all these lines of code, they are meaningful. You have no noise. All these lines of code, they just mean something. For example, you see that remove planet, add score, destroy planet, new planet, and notify everyone. So this code I like it. And actually it's not bad. So first iteration is done. We talked a little about single calls, how we can do server streaming, bidirectional streaming, how we can do simple stuff. Actually, we didn't talk a lot about blocking stuff because it's quite the same as future stuff, but instead of making await, you're just blocked. And future stuff and new stuff, which is not official yet because it's like only comes from Kotlin, it's channel stuff. So first iteration is done, and let's talk a little about interceptors. Actually, I don't like to follow the rules. I want to break my application somehow. So, do you want to break my application too? I want. So let's hack the system. What should we do? I want to write an interceptor that makes my user to receive not like 100 points or 10 points like in this application, but to receive million points independently which planet I destroy. How can we do this? We can implement an interceptor. So we're writing it. We're implementing intercept code there, and let's do it. So let's call it hack the system interceptor. It's this weird stuff, but this is how you should write an interceptors. And in this method, what are we doing? We are having message, we cast it to destroy planet request, and then we check. If username is Margot777, we set weight to our planet 1 million. So it means that whatever planet I destroy, I get 1 million points. So, and then we substitute this message and send it to our server. And in order to make it work, we need to register it. So again, we are returning to our server, and we are saying that we need to register hack the system interceptor. It's pretty simple. You call client interceptors intercept, and you work with it. So we implemented it and have the situation. Do you believe me that it works? Actually, I don't believe myself, so I want to run it. Let's run it. So, yeah, everything works, so we can go to our local host. So, Margot777. Yeah, you see it's my local application, so there is nothing here. And let's destroy this planet. You see that it's 100 points. But I got 1 million points. So it works. Let's return to our presentation. And proceed. Please raise your hand if you are writing code without errors. I guess nobody really writes code without errors, so we need to do somehow error handling. And all happy families are alike, and each unhappy family is unhappy in its own way. By the way, who said this? It was Leo Tolstoy, really cool writer. If you haven't If you haven't read him, you should. So he said that if everything is okay, we don't care what is okay because everything is okay. But if something goes wrong, it's all the time it's something else. So it's considering our error handling. When you have success, you don't care about what's success because it's success. It's okay, so we don't care about it. But if you have errors, you have plenty of errors. For example, in gRPC, you have general errors, you have network failures, you can have protocol errors. And there are a lot, and all of them are handled in different status codes, and you can handle it. But what if your errors are not coming from some network or from your protocol, but they're coming from your business logic? For example, you're trying to create person with an age which is below 0. Which is not really a good solution. So if you want to handle some business errors, you need to think about custom exceptions and how can we handle it in gRPC. If your if your request returns some exception, you will receive status code unknown, which is not what you really need. So you can write an interceptor again and to change its status code with some more meaningful message. So again, you're doing the same stuff, you're doing the same interceptor, but instead of overriding method run, we are overriding method close. So in close, you have access to status code and to metadata. And here you can do some logic and to substitute your status code with something that you need. So it's just an example. You can write your own interceptor. And of course, you need to handle the status code somehow in your client. That's all about custom exceptions. Just think about it. And testing. It's the most important part of my talk. Of course, I'm kidding. So if you're not using gRPC or Kotlin, or if you don't take away anything from my talk, just take away that you need to write tests, because tests are important. And if you are not writing tests, Dart Waiter will come for you, and you know how it goes. So for unit testing in gRPC, there are in-process server builder and in-process channel builder. So instead of generating like a server and the channel, you can have some in-process mock. And here it is, in-process server and in-process channel. And you can give it some name and add some services. Services could be real services or mocked services. And of course, you should not forget to clean up and write tests. Here is a simple example how you can write tests. So you have some stub, you have some observers, and you actually call in method destroy with this observer. And it's simple argument capture and all verify stuff. So writing tests is simple because you're doing the same stuff as you did before. So all the thing you should know is about in-process server and channel builder, and that's all. But it was unit tests. But in real project, we do not write only unit tests. We are writing also integration and end-to-end tests. So what I found is there is no approach to handle end-to-end or integration test, or no unified approach for gRPC. You need to do it on your own. In Wix, we have an approach called test kits. It's a kind of contract testing. And what does it mean for us? If you're writing a Death Star, I mean that service, Death Star, you need to provide all the stuff to test it. For example, some mock stuff, some additional methods, some mocked methods, and it's on your side to help other people to integrate with you and to test your integration, to test their integration with your service. So if you're writing a Death Star, you should be responsible how to test it. And let's summarize. First of all, you should write unit tests. Then you should deal with we can deal with streaming easily because, as I told you, you do the same testing as you did before, and no overhead is gRPC. But unfortunately, we have no unified approach or library for ATO end-to-end test, but at Wix there is testkit approach, and maybe it also will work for you. And the most interesting part is some additional libraries for Kotlin. When I thought, like gRPC, which is asynchronous by default, and Kotlin, where we have coroutines, I thought that we'll have these cool robots. Robots that can save your life in all the situations, can save the world, and to be your friends. In the reality, we had this one, which are not really released, and a little bit with bugs. But let's talk a little bit more specifically. When I tried it to Google and to find some library for gRPC in Kotlin, I found gRPC Kotlin, and I thought that it is an official library, I should use it, and it's okay, it's cool, so it's what I need. But then I find out it's 0.02 version, and I was a little bit surprised, and then I found this note. Actually, this note from the author of this library tells us, don't use me. I was a little bit upset, but in a couple of months, we have version 1.0.10 and all channel support in this library, and as a bonus, all applications that you're playing with was written on top of this gRPC Kotlin stuff, and it's really cool and powerful library, and a guy who wrote it is a really cool guy, and he did a cool job. One more stuff is Proto+. Proto+ is also one more amazing library. When I heard it for the first time, it was only Gradle plugin. It was really hard to use and lack documentation, but it was a few months ago. And now we see that version is bigger, that's have its logo, which is important. And this library is really powerful, and it helps you to make more customization. So you can customize your gRPC Kotlin stuff on your own using this library. So it's also something that worth your attention. And another useful links are gRPC Java Contrib and Reactive gRPC from Salesforce. There are also interesting projects from Salesforce, and which help your gRPC Java to be not that bad as it is. One more thing is protobuf with Kotlin. It's another link. And the last link is my project. You can also play with it, you can dig into it and understand how I wrote it. I played with different frameworks, and maybe you can do some pull requests to my project. And finally, I hope that someday we'll release all these libraries and we'll have perfect support of Kotlin and coroutines and all these features, and and be happy with it. Time to summarize. First of all, you should use gRPC for effective communication. So if you have a lot of clients and you need to somehow make your communication more efficient, to make it faster, you should look into gRPC. But it's only if you have a lot of clients and a lot of requests. Then gRPC plus Kotlin can be used today. So you can use gRPC plus Java, and it's okay. But if you want to make your life simpler and you want to enjoy your programming more, you can go to gRPC plus Kotlin. So gRPC plus Kotlin makes things easier. And we are still waiting for stable versions and cool features, because all the library I told you today are not released, they are in beta versions. And if you want to make it quicker, feel free to contribute, because it's all open source and it's all for you guys. And of course, I told you about some winners and some presents, so let's define some Death Star Master. So what's wrong with it? Actually, maybe something with my connection. Quick and see what's with the application. Oh. Isn't it working, or what? Working. Maybe it's my laptop, so who can name the first guy who is in the scores list? Thomas. So after the talk, just come to me, and I have a present for you from Wix. And let me finish. Okay, so let's say thank you. So there are some people who are behind my back and who helped me to do this talk. So first of all, it's Ray Tsang, who inspired me a lot and who moved me into right direction. Next is Rusbek Delavari, who developed gRPC Kotlin and who reviewed my application to make the use of his library the best. Alex Borisov from Google, who reviewed my slides and make it not so ugly as they were. And this guy, do you know who is he? Yeah. It's George Lucas. And of course, thank you very much for being so passionate and to sitting here and to answering my stupid questions and to listening to me. So thank you very much. And time for questions, if we have this time.